Hello children, this is Pooja Sharma, your physics teacher. Children, as you all are aware of that Cambridge International School DASUYA has taken this initiative to go on with the process of e-learning so that even in this tough situation, you will be able to study smoothly at your home. So, let's get started. So, in the previous video, we have done the introduction to the chapter motion. Now, in this video, we are going to continue with the next topic, that is distance and displacement. So, let's get started. Distance is the actual path covered by an object, whereas displacement is the shortest distance between the initial and the final position along with direction. Now, let's understand what is the difference between distance and displacement. As you already know, distance is the actual path, whereas displacement is the shortest path. So, distance is depending upon the path followed. It does not depend upon any particular direction. So, we can say that distance is a scalar quantity, whereas displacement is the shortest distance, and as I told you that it is always going to be the straight one, so it has a particular direction. That is why we can say that displacement is a vector quantity. Example of distance, if you just say 5 meters or 10 kilometers. Example of displacement, 5 meter east or 10 kilometers west. As here we have included 5 meter, that is magnitude, east, that is direction. So we have both magnitude as well as direction for explaining displacement. Therefore, it is a vector quantity. Let's understand more about this by the following video. So, let's say the object is first at point A, and afterwards the object moves to another point B. Now children, there are many ways to move from point A to B. For example, it can be a straight path. Let's say this is path number 1. It can be a path like this. Let's say this is path number 2. It can be a path like this. Let's say path number 3. Or it can be a path like this. Let's say this is path number 4. So these are the 4 different paths to reach from position A to position B. Now, this path number 1, which is the straight one, because this is the actual path, this is distance. This path number B, this is also the actual one, this is also distance. Path number 3 is also distance. Path number 4 is also distance, because these are the 4 different paths to move from point A to B. So we can say that 1, 2, 3 and 4. These are the different distances to reach from point A to point B. Now coming on to displacement, out of all these 4 paths, which is the shortest one and the straight to go from point A to B? Obviously children, the one which is the shortest is automatically be the straight one. Fine. So, from all the 4 paths, path number 1 is the shortest from A to B. So, this path is called your displacement. Now, this is the actual path, so it is distance. This is the shortest also, so it is displacement. So, from here we can say that if we have the straight path, then the distance and displacement can be same. Okay? Okay, now let's move on to the next slide. Now, let's understand the concept of distance and displacement with the help of an example. In this problem 1, the student is standing at point A and want to go to school, which is at point C. The footprints shown in the figure is the actual path which the student has to follow. The reason behind is this straight path is having bushes in the center. So, the actual path followed by the student is from A to B and then from B to C. This is the distance. And if the student has the direct path A to C, this is the displacement. If we have to find out the distance traveled by the student, so the student goes from point A to B, that is 4 kilometers, and then from B to C, that is 3 kilometers. Therefore, the distance is 4 plus 3, 7 kilometers. If we have to find out the displacement, then if you look in the figure carefully, it's a kind of triangle, that is right angle triangle, where AB is the base, BC is the height, and AC is the hypotenuse. So, by using the concept of Pythagoras theorem, we can substitute the values of base and height, and we can calculate the value of hypotenuse, that is 5 kilometers. Next problem. A dog is at a position where it is written minus 10 meters. Then a tree is at a position where it is written 5 meters. House where it is written 15 meters. Suppose the dog has to reach from the position minus 10 meter to the tree, that is 5 meter. So the distance traveled by the dog is final minus initial position, that is subtraction of minus 10 from 5. It's going to be 15 meters. If we want to find out the displacement in this case, it's going to be the same as that of distance. The reason behind, because the path is the straight. So it is the actual path as well as the shortest path. This is the reason that the displacement and the distance, they both are 15. Let's do another example. A man is at point A. After some time, the man reaches to the point where it is written B. And then after some time, it reaches to a point where it is written C. Now, in this figure, if we have to find out the distance covered by the man from point A to B, then it is 9 minus 0, that is 9 meters. And if we have to find out the displacement from A to B, it's also going to be same. As we have done earlier, if the path is the straight and the shortest, the distance and displacement are going to be same. Next, suppose the man reaches from A to B and then from B to C. We have to find out the distance from A to C. Therefore, we have to find out the distance from A to B and then from B to C. That is 9 steps plus 4 steps more. That is 9 plus 4, 13 meters. Whereas, if you have to find out the displacement in this case, we will not consider the path followed, because displacement is irrespective of the path followed by the person. Therefore, the starting position, that is the initial position, is A, where it is written 0. The final position is C, where it is written 4. Therefore, where it is written 5. Therefore, the displacement is final minus initial, that is 5 minus 0 is equal to 5 meter. I hope from these examples, these problems, you will be able to understand the concept of distance and displacement well. Now, my question to you is, when the displacement be equal to distance? We have already done the answer in the previous examples. Next question is, when can displacement be 0? So, my dear students, displacement can be 0 if in problem number 3, the man goes from A to B then from B to C, and from C to A back. So in this case, the point from where the man started reaches back to the same point. So the initial and the final position are same, therefore the displacement will be 0. What I mean to say is that if the path is closed one, the displacement is going to be 0. Thank you so much. I hope you understand and you enjoy it. Stay safe, stay healthy.